This lesson will discuss how to solve quadratic application problems, word problems. So let's review the important things you should know in order to do that. First, make sure you read the problem. I know that sounds very basic and simple, but too many times students will try to just pull numbers and guess what to do with it. So make sure you read the problem several times if necessary until you understand what it is they've told you and what it is that you are to find. After that, assign a variable to represent the unknown value and use diagrams or tables as needed. If you read a word that you know is something you can draw, such as rectangle or right triangle, be sure that you draw that figure. It will help you in organizing your information and understanding what to do. And I'll try to help you understand which missing piece, if there's more than one you're looking for, that you should decide to call X. Sometimes that's a little confusing as well. So we'll review that. Write an equation using the variable expression. So obviously figuring out what we're looking for and assigning variables to it is necessary in order to write an equation, but you need to write the equation in order to solve for the value that we're trying to find. After you solve it, be sure you state the answer somewhere on your paper. You need to say what it was that you found. Check to make sure your answer seems reasonable, and we'll discuss that as we look at some examples too. And go back and check the answer in the words of the original problem and just make sure it seems that it's logical. So let's start with the first example, which would be the length of a rectangular room is 2 meters more than the width. The area of the floor is 48 meters squared. Find the length and width of the room. Okay, so we understand that we're trying to find the length and the width of the room. So we're going to need to decide what to call the length and what to call the width. Now, because it's talking about a rectangular room, I know I can draw a rectangle, and I'm going to do that. When I go to the words of the problem, here's what I have to figure out. Is one of these going to be X and the other one something I write in terms of X? That should be what happens. And as I look at this problem, I want to look for the word than. Than is a comparison term. So typically I'm going to see more than, or I'm going to see less than. And when I see this more than, whatever follows the word than should be what I call X, because the other thing is getting compared to it. So I need to figure out what was the starting point. What is everything getting compared to? In this case, it's the width. So if the width is going to be X, and it tells me the length is 2 meters more than the width, I should recall more than is an expression that means I'm adding something. It's going to be 2 meters plus the width. That tells me X plus 2 or 2 plus X is going to be my length. Okay, so I have now drawn my diagram, identified what I'm looking for, and assigned variables to it. I'm ready to write an equation. The piece of information we haven't used yet from this problem is what the last sentence says. The area of the floor is 48 meters squared. When I see that word area, I need to know how I find area of a rectangle. And if you remember, possibly from middle school or high school, you probably worked some area problems for rectangles, and area is equal to length times width. So now I just need to substitute in the information I've been given. The area is 48 meters squared. Now I'm going to make a suggestion. I would not put the unit into the problem. I will put the unit on my answer. And so when I get to the part where I have to identify my width and my length, I'm going to remember that they will be in terms of meters. But for now, I don't need it in the equation. So my area was 48 and my length was X plus 2. And I'm going to keep that in parentheses because that entire x plus 2 expression represents my length. My width is x. And I now have an equation I can solve. In order to solve it, remember when it's quadratic, we've got to first of all get rid of the parentheses, so we'll have to use distributive property on the right, multiply it through. We're going to get 48 is equal to x squared plus 2x. And because there is an x squared in the problem, everything needs to go to the same side and set it equal to 0 before I solve. Since my x squared is on the right and it's already a positive value, I'm going to move the 48 to the right. So I'll subtract 48 from each side. That will give me 0 equals x squared plus 2x minus 48 on the right side. Now, at this point, I go back to what we learned about factoring. I'm looking for a pair of numbers that will multiply to give me a negative 48, add to give me a positive 2. Because it multiplies to give me a negative, I know I need a pair of numbers where one is negative, one is positive. And the pair that's going to work that will multiply to give me negative 48, add to give me positive 2, has to be a negative 6 and a positive 8. 6 times 8 gives me 48. In order for it to be negative, though, I know one of these needs to have a negative sign. My larger number should take the same sign as the middle term. So that's why if I use positive 8, negative 6, it will satisfy all the conditions for factoring. And I'm ready to write this in factored form now. So that means x minus 6 is in one parenthesis, x plus 8 is in the other. I can set each parenthesis equal to 0 and solve. And if x minus 6 equals 0 or x plus 8 equals 0, then x could either equal a positive 6 or a negative 8. Now this is where you have to stop and think for a moment. What was I looking for? X stood for the width of this rectangle. Is it possible for a measurement of width or length to be a negative number? No, it's not. Anytime I measure a distance, it's got to be a positive number. So the negative doesn't make sense in this problem. I will choose positive 6 for my answer. And that means I can come back to the top now. My width is 6 meters, and my length would be 6 plus 2, which is 8 meters. Here's where I defined it. I've now given the value for the length and the width, and I check to see if it makes sense in the words of the original problem. If my width is 6 meters, my length is 8 meters, I do know the length is 2 meters more than the width, and if I multiply those together to get area, I do get 48 meters squared. So that would be an example of how to do a rectangular area problem. Now, another type of quadratic problem that you may see is a consecutive integer problem. Consecutive simply means right next to each other. So if we're talking about consecutive integers, that's what happens when you simply count numbers. If I start with 1, the next number is 2. How did I get there? I added 1 to it. If I want to get to the very next number, I add 1 again. So as long as they're consecutive integers, our pattern would be if the first number is x, because we probably won't know what the number is, we just know there is a number we start with. If I need the next consecutive integer, I add 1 to it. So x plus 1, x plus 2 would give us consecutive integers. Whether they're consecutive even or they're consecutive odd, think about it for a moment. If I'm only counting even numbers, I have to skip over the odd number that's in between. So I don't add 1 to get to the next number, I have to add 2. 1, 3, 5, those would be consecutive odd numbers. But notice I'm still adding 2 because I had to skip over the even number that was in between. So whether it's consecutive even or it's consecutive odd, the pattern changes slightly and we have to add 2 to get to the very next number. So keep that in mind as we try to work this next problem. And it tells us that the product of two consecutive even integers is 4 more than 2 times their sum. We're going to find the integers. Now, I can't draw a picture on this, but I do recognize what it's asking me to find. It says find the integers, and if I go back to the first sentence, I'm looking for two consecutive even integers. So my first integer, I'll define to be x. My second integer, since they're consecutive even, remember I've got to skip over a number, so it's going to be x plus 2. Even if it had said consecutive odd, I would still have written x plus 2. The difference is when I solve for x, I should have gotten an odd number. In this problem, because it says two consecutive even integers, when I solve for x, I know I should get an even number. So let's look at how to translate this into an equation now. Since we've identified the variable, we're ready to do that. And I noticed some keywords here. I see the word product. That means the answer I get when I multiply. So I'm going to be multiplying what? My two consecutive even integers. Well, that means I have to multiply x times x plus 2. The word is, when it's all by itself, it doesn't have is more than or is less than, is the word that is typically used that means equals. So I'm going to put an equal sign. Now I see 4 more than, remember we talked about this in the last problem, that means I'm going to be adding, so I'm going to have 4 more than, so a plus sign, 2 times their sum. Okay, when I see that word sum, I need to remember that's the answer to an addition problem. And because it says 2 times their sum, it means 2 times what I get when I add those two consecutive even integers. So if I go back and look at how I defined them, that's x plus 2. And at this point, I have an equation. It's a little messy. I'm going to have to get rid of all these parentheses and see what I have after I've cleaned it up a bit. Distributive property on the left side gives me x squared plus 2x equals on the right side. I do have some terms I can combine inside the parentheses. So when I add the x plus x, that gives me 2x plus the 2 that was already there. And I'm ready to use distributive property on the right side, and then we'll start combining like terms. And I'm going to have 4 plus 2 times 2x is 4x plus 2 times 2 is 4 on the right. Okay, I know I can add the 4 plus 4 on the right side. That's going to give me a plus 8 on the right. And I have an x squared on the left. It is positive. I'm going to want to move everything to the left side. And that's going to give me x squared. When I subtract 4x from each side, that gives me a minus 2x. And then when I subtract the 8, that's going to turn into a minus 8 on the left, leaving 0 on the right. Okay, it's time to factor. What pair of numbers would multiply to give me a negative 8, add to give me a negative 2? That's going to be a negative 4 and a positive 2. I can double check that using FOIL or the box to make sure that it actually does multiply back out to give me the original quadratic that I had. It will. Now I set each of these individual pieces equal to 0 and solve. So either x minus 4 equals 0 or x plus 2 equals 0. And what I will get is x equals 4 or x equals negative 2. Now, the fact that it's a negative number does not automatically mean we can't use it. If we go back and we read the question again, what were we looking for? Two consecutive even integers. Are both of these even numbers? The answer is yes. So that means for this problem, we're actually going to get two possible solution sets. Sometimes you may do this and you get one number that was an even number and one that's an odd number. If that happens, we can't use the odd number because obviously it doesn't satisfy the original problem, which said we were looking for an even number. So read carefully. Excuse me, in this case, I know it's possible that the first number could be a positive 4. And if it is, 4 plus 2 is 6. Now let's check and make sure this pair really works. The product of these numbers, 4 times 6 is 24. Is that 4 more than 2 times their sum? Well, their sum is 4 plus 6, which is 10. 2 times that is 20. If I add 4 to it, I do get 24. So that would actually satisfy the problem. Now, let's try the other pair. If x is negative 2, when I add 2 to that, I'm going to get 0. Now let's check this. The product of negative 2 and 0 is 0, and that is the case. Is that 4 more than 2 times their sum? Well, if I add the sum, negative 2 plus 0 is a negative 2. 2 times that would be a negative 4. When I add 4 to negative 4, I do get 0. So we have 2 possible solution sets for this problem, and we would want to give both of those as answers. Third type of example is a problem that uses Pythagorean theorem. You may recall Pythagorean theorem is a squared plus b squared equals c squared. It is used only with right triangles. The one rule you have to be sure you don't forget is that the c represents the hypotenuse. So that's going to be the longest side in the right triangle. And when I read this problem, it says the hypotenuse of a right triangle is 3 inches longer than the longer leg. The shorter leg is 3 inches shorter than the longer leg. Find the lengths of the sides of the triangle. So one thing I recognized because of the word right triangle, I can actually draw a right triangle, and because it talked about a longer leg and a shorter leg, I want to make sure I don't make the right triangle look like the legs are the same size. So there's my right angle, and I have to figure out of these sides, what's my starting point? Which one should I call x? So remember what we discussed before. If you read the problem, do you see the word than? That we've got something that's being compared. So when I read the first sentence, the hypotenuse of the right triangle is 3 inches longer than what? The longer leg. That's what follows. Now let's check the next sentence because it says the shorter leg is 3 inches shorter than the longer leg. Okay, these two that I boxed, are they the same thing? They are. Since both of these sentences compare something to the longer leg, that means the longer leg should be x. So when we finish this problem, we're going to know that the longer leg was x. We're going to come up with something for the shorter leg, and we're going to come up with something for the hypotenuse. Now, let's go back and start at the beginning. The hypotenuse is 3 inches longer than the longer leg. That means it would have to be x plus 3. And the second sentence tells us that the shorter leg is 3 inches shorter than the longer leg. That would tell us the shorter leg must be x minus 3. So now that we've got our diagram and we've defined the 3 things we are searching for, because notice it says find the lengths of the sides of the triangle, it's time to go to Pythagorean theorem. A squared plus b squared equals c squared, and we will substitute in. Remember, the hypotenuse is the only one that has to be identified as a particular letter. It will be c. I get to decide which of the other two I want to call a and which one I want to call b. So if I plug in, I can make x squared plus, now be very careful on this, the entire shorter leg is getting squared. That means I better put that x minus 3 in parentheses before I square it. And the entire hypotenuse, which is x plus 3, is also getting squared. Now this is where you better be careful that you pay attention. It is a binomial, 2 terms that's being squared. We discussed this in the earlier review lesson. That means you have to use FOIL or use the box. If you have forgotten how to do that, refer back to that review lesson. And we will end up with x squared plus x squared minus 6x plus 9 on the left side. We will have x squared plus 6x plus 9 on the right side. Again, if you need to review how to use FOIL or use the box, look at the other review lesson. There is an example included there. Once we have multiplied this out, gotten rid of our parentheses. It's time to combine like terms. Notice on the left, I have 2x squareds. So 2x squared minus 6x plus 9 is equal to x squared plus 6x plus 9 on the right. And since I have x squareds on both sides, I want to move everything to the side where the x squared is larger. In this case, I'm going to move it to the left. So I need to subtract x squared from each side. I will subtract 6x from each side, and I will subtract 9. When that happens, obviously everything has canceled on the right, and on the left, 2x squared minus x squared is just x squared. A negative 6x minus 6x is minus 12x, and look what happened to our 9s. 9 minus 9 cancels out, and I have x squared minus 12x equals 0. Now, this one will not factor as the others did. It is not an AC method type of factoring. Remember, the first thing you're always supposed to look for when factoring is, do I have a common factor? And in this one you do. It is x. So when we factor out x, we'll get x minus 12 in parentheses. And I still have two possible answers here. Either x can equal 0 or x minus 12 can equal 0, which would mean that x could equal 12. Now, remember what you're looking for, sides of a triangle. Would it make sense that if I had a side that was 0 in length, that I have a triangle? Obviously not. This is not a logical solution. It was a possible answer, but it doesn't make sense in the problem. Therefore, x must equal 12. So if I come back to the original way I defined my variables, that longer leg was x, so it's going to have a length of 12. Now when I read that problem, don't forget this is where units will come back in. And it speaks of the hypotenuse being 3 inches longer than the longer leg. That tells me my unit of measure is in inches, so it's 12 inches for the longer leg. The shorter leg is 12 minus 3, which is 9 inches. And that would make my hypotenuse 12 plus 3, which is 15 inches. And I have now defined and solved for all 3 sides of the triangle.